team was working on the Bitcoin network. First, I would like to introduce what is the Bitcoin, then introduce our data sets that you have, and I will be talking about some statistical properties of our network. Then David will tell us about how did we visualize our network, what interesting did you find when visualizing, and then Valentin will tell us about dynamics of the Bitcoin network. So what is the Bitcoin? Bitcoin is a cryptocurrency. It was invented in 2009, like an alternative to the normal banking system. And how it works? It works like a banking system with the only one difference. Like when you make transactions via banking system, so we rely on banks, and every transactions we have on bank ledger. And in Bitcoin system, the ledger is open source, so everyone can see which transactions were made and when. And it makes the system like it's decentralized currency. We don't need banks. We don't need any central entity anymore. So that's a brief description of what is the Bitcoin and our data. So we have transaction data from January 2009 to January 2013. It's 4-year transaction history. And in total, we had more than 25 million transactions. And our data will look like we have source wallet, we have target wallet, we have some amount of Bitcoins that were sent from one wallet to another, and we have information about the timestamp. Since you have data only from 2009 till 2013, we analyze this period, but this graph shows us how activity in Bitcoin systems were evolving during the time. It was very non-popular in 2009, and by now we can see that it developed a lot. And this graph shows us how price of Bitcoins were changing. Price of Bitcoin to USD. So it was very cheap in the early period, and now it's more than 1,000 USD per one Bitcoin. It's just visualizations of 1 week transactions of one of the last week of our data set. And red color of edges means that our node has very high degree. And green lines, yellow lines, they tell us about that our node has small degree. And one of our team members, who is not present today, he was also playing with Jeffy, so he found some nodes that were kind of isolated, only self-loops. They were not actually trading with any other nodes, only with themselves. So it's visualizations of isolated nodes. And we have calculated some basic statistics for the Bitcoin network. It's like number of nodes, and plotted the evolution of how number of nodes were changing in our time period in 4 years. Also, we calculated number of edges, and you also can see that number of edges were developing during the time, and also average degree distribution. So in first few months, average degree distributions of our network was equal to 1. And it says that people were using like Bitcoin system only sent once and then forget about their wallet. But with the time, we see that average degree is growing up, which means that people become using this Bitcoin network more and more, not like for only one transaction. Also, since our data was quite big, we decided to divide our data set into 2 parts. So first part is first 2 years, from January 2009 till January 2011, when Bitcoin was not so popular, and we analyzed these 2 data sets separately. So this slide shows us the overall degree distributions in our early period. And we can see that it's kind of Powerwall. And when we are analyzing the degree distributions in later periods, it shows that our network is scale-free. Also, we analyzed separately in-degree distributions and out-degree distributions for early periods and for late periods. And in both slides, we can see that in-degree distributions is more fitted to Powerwall than out-degree distributions. And we can actually explain this like it really makes more sense, because in-degree means that we have received some amount of money, and it tends to be heterogeneous. But out-degree is, it could be more homogeneous, because out-degree, it means that we were sending the money. So it's not weighted, so we just see that some transactions were made by some wallet. So in-degree distributions in both periods showed that it's Powerwall, it's scale-free network. And some interesting conclusions that we can make looking at the degree distributions of our network is that in Bitcoin network, like in any financial network, I mean, in real financial and economic system, the distributions of wealth is very heterogeneous. So very few people own a lot of money, and most of people, they have less money. And also here the plot of our weight distributions. By weight, we took the amount of Bitcoins that were sent from one user to another. And so from here we also can see that most of people were trading with small amounts, and less people using like big amounts to make transactions. And for Bitcoin Safari, visualization of our networks, David will explain.
So Ayana's introduced the sort of overall distributions of the properties of the network. Once you sort of start looking at it, you might, well, once you look at the graph, the degree distribution, it has the property of this sort of general scale-free network. But that's not, well, then we want to see is that, you know, can we tell something by inspecting the network about some of the sort of underlying mechanisms that are generating it? And, you know, we don't have any information about what the nodes represent, but can we maybe infer something about what's going on in the Bitcoin community by looking at some of the structures? So the way our sort of analysis proceeded was quite exploratory. We ended up searching through and just visualizing the network in different ways, finding what's interesting, and we found a lot of creatures that are sort of hidden there in the network that I'll be walking through a few of them. So the first thing we noticed when we fed some of the data into Gephi is a large number of isolates, and then when you use the force atlas algorithm to visualize this network with lots of isolates, you end up with something that resembles the solar system, or as we were sort of calling it, the pancake. The isolates, for one reason we think the isolates are created in this network is through the mining process. A desktop computer that's running the Bitcoin sort of cryptographic algorithm can create it. That's how Bitcoins can get created. And some of the isolates appear to be driven by that process. So one thing then we did, that's less interesting from a transactional network point of view. So deleting them and then exploring a little bit about the clusters in the network. So this is where we start seeing some patterns emerging. We've got pretty strong clusters, strong evidence of clusters where there's essentially one at each of these big blobs. There's one node at the center of it, and the blob is made of one node that either sends Bitcoins to 1,000 other wallets or receives Bitcoins from 1,000 other wallets. We can only sort of speculate about what the exact nature of these is, but it could be something to do with a Bitcoin exchange. So if you want to buy Bitcoins with US dollars, you need to you set up a wallet, you send your dollars through the normal banking system to the exchange, and then the exchange will send you the Bitcoins to your wallet. So that kind of intermediary platform, we would probably produce this kind of structure. Here's zooming in on a few of these different clusters. As you can see, this white node at the center is transacting with lots of these other counterparties, many of which don't have any other transaction, some of which are transacting with themselves. In some cases, you have like clusters of blobs. So here were two that were next to each other. And then here's sort of a tree where we had one that was splintering off into different sort of sub-blobs. So this is our sort of working theory, is that there's some sort of financial intermediation organizations. This actually led us to look back at the table and find that there's lots of nodes with Indegree of 1 and Outdegree of 2. And the two transactions that were going out from the wallet, one of them was a very small amount that went into one of the very central nodes. So it looks like it looked like a sort of a several percent of a given Bitcoin transaction that was being sort of maybe paid as commission into a central wallet. Which actually is, well, from the perspective of the aims of Bitcoin, it's quite interesting, because many of the sort of ideological proponents of Bitcoin want to use it to get rid of intermediaries and make financial transfers frictionless. But it seems that these intermediaries have grown up with the Bitcoin ecosystem. If you remove the small network, all the small transfers of less than 1 Bitcoin, you end up with a very different structure. So here is what it looks like in aggregate. You can zoom in on a little bit here. This structure here is really a set of chains where you have one wallet transferring to another, to another, to another, and the average path length in this network is over 1,000. The network diameter is 6,000. I think this is with a node. This is with about 50,000 nodes in the network. In comparison, if you delete all the large transactions and look at only the small transactions, you get a totally hierarchical, centralized tree-like network. It's a set of branches with an average path length of under 10 and a network diameter of 128. So just comparing those two, this is I guess one interesting discovery that we don't know exactly how to interpret, but what we're seeing is that Bitcoin actually is almost two separate networks layered on top of one another. The large network made up of what we think resembles a ball of string, and then this network here with interesting structures like this, so almost like a chandelier, branching in several steps. Okay, and I'll hand over to Valentin.
My main task was to make Gephi visualize our network dynamically, and finally I managed to do this. We visualized the period of first half of 2010, and from previous graphs you can know already that there were not so many users of Bitcoin, but still we can encounter interesting behavior, and so you will soon see another cluster appear, and total increase in nodes is very significant starting from July of 2010. Yes, here it is, and look what is happening with the cluster which is here, with this cluster, if you move further. Yeah, it transfers into chain of nodes. So what does it mean? That they are controlled by one, let's say, holder. who was first using them to mine, let's say, bitcoins, and then at some point he decided he will use them to hide the traces of his transactions. And this is actually a very, very interesting finding, I think. And also to see evolving and dynamic networks is makes sense. Yeah. Finish?
And that's all. Thank you.
We're running out of microphones. Questions?
Still moving.
Really cool things you guys have done. I don't think I understand anything of it, so that's nice. So the graph you showed about the edges, can you go back to that? Because there it was a little bit fast for me. No, so that wasn't good. One more, that's it. So that coincides with the, I mean, if you look at this peak there, what is it, in July,
In
August,
July
something like.
2007.
Does that coincide with the peak that we saw on the
Yeah.
total amount? Ah, okay. So
It coincides
yeah,
with the price of.
yeah, exactly. So that did coincide with that. We would
Yeah.
overlay it. We do the same.
Yeah.
And that totally makes sense.
Yeah.
Because the number of edges,
Edges is the number of transactions. Not the
Yeah.
volume, but it's the number of transactions.
it's not a volume.
But you would,
It's
you
not
would
pure.
assume it correlates. The more
Yeah,
transactions,
but
there
it
is more
seems to
volume.
be like really one-to-one.
Yeah.
I'm not sure I understand that.
Second peak seems or the first peak seems lower here, right? Could be speculation that they thought it was worth more. Is that possible?
I don't know. So let's see. So this says June, what is it, June 11?
Yeah.
Yes.
And then you go to the other one?
So
So it doesn't.
that's peak.
Does that peak?
Oh.
There you go. That's where I got it. Okay, so it doesn't overlap. And then look at 214 in your edges thingy.
You don't have
We
it.
don't have.
I don't have to, of course.
You have only beginning of
If you
2013.
Go back by one.
Back.
So this one is actively, yes, this one would be roughly the same.
Right,
This is the
Yeah,
edges, right?
right. But then you don't see that anymore.
You see a small peak, the scale
Yeah.
is so small.
Thanks.
What questions?
So, I mean, it's really, I'm just trying to get my mind around this whole thing, and I won't manage. But so the fact that you have two graphs, right? One, so the high, the one with the smaller ones, so to say, and the one with the big ones. So could that have something to do with like early adapters that just try a little bit to do things, with the Bitcoin and just play with it, like I would probably do. I spend like $10 or something like that. But and then the big guys that do the real big things. Could it be something like that, that you're actually looking at two totally different behavioral groups? And if so, then you should see some kind of time effect in that, because the guys that really do the big transactions, they want to make big money, and they keep on going, and the other ones basically try and then they step out again. Would this make sense?
This is what is proving your hypothesis that there are thousands and thousands of those who try and then give up,
It's
don't do anything, and don't connect and transact these bitcoins to anyone, and we don't see them any longer. And maybe you comment this.
Check with this. So if you look at the average degree in one node versus the other of the time, that will tell you are these people having frequent transactions. But most of them, it seems to be the fact that it's a chain is pretty strange, because these are different users transferring one to the other and never back. It's very, very weird.
Yes, very weird. So
at the end of the day,
It's going.
the thing that you would like to understand actually is how these transactions actually impact the price of the Bitcoin. is there any hint on how you can actually understand that that specific concern?
So the best explanation I've heard for price of Bitcoin, which we didn't have time to actually analyze, is so it's that it's related to it's closely correlates the number of nodes in the network. Which we haven't got the relevant data to show that, but almost the value of a coin depends on what other people will value it at, and the more people in the network, the more it gets valued. But
maybe actually, if you look at I think I have an idea of what is the total number of nodes, and if you look at the total number of nodes, I'm not sure if you have that flat, but the total number of nodes will show that in fact it is not that it is not too correlated with the price. I'm more wondering whether the structure that you've been showing here, including the possibility that if there is an increase in the entropy of the system, it's probably correlated to some spike in the pricing of the Bitcoin. I don't know. I am just trying to speculate on this one. It's a very interesting work. Very interesting. But one last comment probably, and I think this is a comment for, I think it was not properly emphasized in the winter school regarding power law. I've seen that everyone is trying to fit everything to power law. One main comment is that at least visually, for you to be able to see a power law, it should have 3 orders of magnitude because it is a log-log plot. Like 2 points determine the line, but in the log-log plot, you need at least 3 orders of magnitude to be able to see a power law. But in most cases, there are a lot of data. Like for example, this is less than 2 orders of magnitude. Okay, exponential will also fit well with this kind of data. So actually, Peter mentioned one of those works. It is actually by Closet in 2007, where if you have less than 2 orders of magnitude, that kind of fitting perspective will be useful. So the main idea is that power laws, derivative, for example, or integral is different from, for example, if you have an exponential, you get another exponential, but power law, you will have a different exponent. So those kind of perspective would be useful to make sure that it is a power law. But this is an interesting work.
thank you.
Okay, good job. So now we come to our last thing.